What's up, everybody? Welcome to the Juju Show, episode 46. Back in action. I missed one last time. I gotta admit, the little meeting invite hit up on my calendar, and I went, I'm not ready, and so I had to bail. So this is a makeup episode. So to make it up, I found someone more awesome than me to come do awesome stuff, and then that way everyone gets a treat. So speaking of guests, let's go around. Corey, how you doing?
I'm doing well. How are you?
Having fun. Spring is finally here. I'm gonna go mountain biking after work today. I'm excited.
Nice.
I think I'm only gonna be able to ride part of the trails because they're gonna be still wet and thawing and whatever. But part of them are okay. I'm pretty sure.
It's pretty nice here. We might go hiking on Friday.
Oh, it's awesome. Yeah. Beatty, how about you? How's the weather out in the Pacific Northwest?
It's cold and gray today, but spring's here still. That's just the way spring is here.
There you go. We'll take it. Ken, where are you calling in from?
Calling in from Minnesota, which is actually relatively snow-free and sunny.
See, it's hitting everywhere. Birds are in the air. So Ken or Kenneth? You got to correct me. Catch me up.
Just Ken is fine.
Just Ken is fine. Good. I like short, sweet. Awesome. Kevin, how are you doing?
Pretty snow-free in Austin too.
Austin, man, I gotta come to Austin. They got a new lift access mountain bike park. I have to go hit Spider Mountain.
Okay.
Oh, he has all the toys and doesn't even know how to appreciate it, man. All right,
I'll Google that later.
Yeah, all right, yes. Google Spider Mountain and then invite me over. That's what you got to do. All right, so let's see. Speaking of toys, 253 released this week. Yay! There was much rejoicing. Bug fix release, nothing crazy. If you had KVMs and you did a bunch of the same applications on the same machine, there were some issues there. Some small tweaks, updating some status stuff to be nicer and cleaner. So nothing too major, but just a heads up. You got more awesome stuff coming in 253. Keep your stuff up to date. I will say there is a 254 coming soon because there was a small upgrade issue identified by some stakeholders this week going from 2.4 to 2.5. But that will be out at the beginning of next week. We got it to QA today, and they're going to run with it over the weekend. So, nice, regular, repeatable, keeping things running along, making it better every time. So,
hey, props to the release team too. I noticed that Brew was updated to 2.53. I think same day as the Snap went up. So that's awesome for Mac people to Brew update upgrade.
Yep. Actually, I gotta go run that on the Mac I got over there somewhere. But yes, definitely. I like having it on my Mac myself, so it's always good there. Speaking of things, just to kind of precede the excitement. The team is looking to lock down Juju 2.6, the next big release with big feature-y stuff and all that, in 3 weeks, 2.5 weeks or whatever, basically mid-April. It'll be locked down for RCs. It needs to be out the door by the end of April. So you will see us doing things like call for testing. If you've got any feedback or you want to have any input and stuff, now is the time. Try that Edge snap out and let us know how 2.6 looks for you. Maybe throw it in some CI or something, have some fun. Let us know how it goes. So just a little dangle candy for the future. All right. What's changed since we chatted last time? Well, you know what? I don't know if everyone noticed or not, but the documentation, the official documentation has moved from GitHub to Discourse. There's now a new section in Discourse for the documentation, and folks can, I think right now there's a reputation level. You have to participate so much before you get write access, but anyone can comment feedback on docs, and the goal is to get it to where folks are able to see something wrong, fix something wrong, make it right now better right away. And so join making the documentation bigger, badder, and better as a community as a whole. So we appreciate all the participation in there. So it was kind of fun. There was a comment posted in there today about some of the new Kubernetes documentation was some of the best documentation they'd seen around. So I just wanted to call out the folks that work on the Kubernetes docs and material there. It's awesome to hear that folks in the community are trying it out and finding it amazing and awesome. Great work. Next up, Kevin, thank you for doing this. I had this on my to-do yesterday, and then I had a meeting, and then I ran away, and I didn't get back to it, and then you beat me to it. The promulgation request for the content cache charm. So I had to go look at what this did, because I'm like, content cache, like, how so? For so? Like, what do you mean? And it looks like it throws up an Nginx, basically proxy cache, able to be thrown in front of various services to actually do, like, content caching, like your own CDN if you wanted to, kind of thing. So I haven't gone too deep into all the wizardry and stuff in there, but that seems like it'd be kind of cool, especially with, you know, all the clouds running, you know, running things these days. You can kind of throw up your own kind of content caches around all over the place, or even on your internal network if you've got various, you know, networks across your company, or you know, your own data center kind of things or whatnot. You can throw your own stuff in your own cache and not have to worry about getting things on the public side or whatnot. So kind of cool. Encourage folks to check it out. And as always, you know, give it a shakedown, try it out. And if you have any feedback or anything, I'm sure they'll love to get that feedback. Next, ApacheCon. Who's going to ApacheCon? Anyone? We don't know yet? No. Well, it looks like we've got some community folks going to ApacheCon. I can only think of Magical Trout. I'm blanking. What's his real name?
Tom Barber.
Tom Barber. Sorry. Yes. See, there you go. IRC, man. It's going to be the death of me. I can remember IRC names. So Tom submitted a bunch of presentations to go, particularly around, this is, you know, ApacheCon, big data space. This is lots of charming of big data applications and things. And so I encourage folks to check out his post, basically getting anyone interested in I think, participating. And I'm sure you could find Tom there and give him a high five for some of the work that they've done, some of the charms they've got put up. And it's just a general trying to get the community at large to buy in that the charms are awesome. One of my favorite stories around charming early on was we were at a config management camp, and there was a guy there from, I forget the name of the tool, but it was like a visualization tool that sat on top of a Hadoop stack. And he thought the charms were awesome because half of the work to get people to try his visualization tool was to get all this big data stack up. So it was kind of, because it was at the end of the pipe of all the tooling, he was like, oh, this sucks. The first thing I have to tell you to do is all these steps. It has nothing to do with the software that I care about. And when he got into the charming side, I was like, wait, I can make this be really simple. Juju deploy the whole Hadoop stack and then go grab my thing and put it in front of it. And now you can play with it easier. It was a real big win for him. And I thought that was a really kind of cool story of letting the charms and all that take care of the crap you don't want to have to care about and letting you focus in on the stuff you do care about. So hopefully that story and those kinds of things spread at ApacheCon. And we hope Tom is successful and gets lots of good talks in. Let's see. Is there anything particularly awesome anyone saw? Building big data platforms. Apache drew it on Kubernetes without a PhD. Oh, man. And I gotta love the data management for dummies. We'll have to see how that goes.
Yeah, A+ in title talks. Magical Trout. That's the way to get accepted.
There you go. Let's see. Next discussion I thought was interesting was the small Kates discussion, where someone was like, hey, I'm trying to use Canonical Kubernetes bundle. We use it in production on this MAS, but I want to test with it. Can I scale it all down to ones and still use it okay, or is that a problem? I mentioned microkates, wondering if that would just be enough to do development without having to spin stuff up. But in particular, they needed moving bits that were in the actual Canonical Kubernetes side of things. And so what was great was Tim got in and was like, scale it down to your heart's content, use it, love it, develop against it, beat on it. But kind of cool. I think it covers that whole gamut of, you know, I've got some Kubernetes stuff I'm trying to develop and work and test on. And we can go, yeah, well, all the way down from just your local machine, then run it all the way up to production. So pick your size. Anyone done that? Running their own little small micro Kubernetes anywhere?
Yes, all the time when I need to deploy something quickly. And I'm like, I don't want to wait for two masters to figure out which one's a leader. Just drop them down to one unit a piece and be done.
Be done. Awesome.
But I mean, microkates is a great suggestion as well, depending on what type of development and test. I know you mentioned they wanted some of the other moving parts, but truly the smallest Kates. Just snap install microkates and you're done.
Yeah. I don't know if you guys saw, there was I think Istio did a microkates walkthrough YouTube thing on like a live streamy thing a few weeks ago. That was a lot of fun to watch. I should try to find the link to that and post it in here. I thought that was cool. Oh, this is an oldie but a goodie. So someone else, I think it was our friends over in the Scania world. Yeah, Eric. They found an old post from Jeff around embedding the Juju Cli in the GUI, where you can basically get a terminal that's preceded with the Juju info for the controller and issue CLI commands through a web browser against stuff. And this is something that was done a while ago, but what was fun was that Eric recently found this and tried it out and had a great result with it and thought it was awesome. So consider this your regular reminder of there are things out there that you may have seen and forgot about that might still be kind of cool and useful and handy. I know particularly, I mean, for me, I use it like around presentations because it's great to just keep a browser up. And like if I'm doing a live stream, I can just share the browser window and get both terminal output and browser output without switching back and forth between which application I'm sharing on my computer. Or even if I'm doing like a live talk or whatnot, it's nice to just drop straight into a terminal on there and you get both that visualization from the GUI plus the terminal all baked in. It just simplifies some of that demonstration purpose stuff. But I think in their use case, they're looking at actually giving people just access to a web browser without needing to have access to the local client on their machines and stuff and being able to work and do things. So consider that another cool thing that's out there that folks forget about sometimes. Anyone use it lately? Did we all forget about it? All right. It is now remembered. We'll go from there. All right, Ken, are you ready? I've been promised awesomeness with Kubeflow, and I get to ask all the nice dumb questions.
Sure.
Awesome. Take it away.
All right. Yeah, so I can be showing how to deploy Kubeflow with Juju. And just for some background, Kubeflow is a collection of machine learning tools that, or it's integration between various machine learning tools in Kubernetes. And as the name might imply, Tensorflow is one of the main tools. I'll open up the charm here. So we can see that right now we're deploying Tensorflow as well as Jupyter Hub. Kubeflow also supports a number of other machine learning tools, such as Selden and PyTorch. And we're working on getting those integrated. But just to demonstrate how easy it is to get started, I'm going to deploy it here. So just Juju deploy Kubeflow, and it'll go talk to the charm store, grab all the charms in the bundle, and go and deploy them. And this is slightly misleading because there's actually a little bit of prep that I will show you in just a second here. But you can see we got the charms deployed, and then I'll run a script that will wait for them and then print out some useful information.
So I saw like operator and stuff go by there. So can you tell me this doesn't seem like my normal Juju deployment?
Yeah. So deploying things on Kubernetes is a little bit different than deploying it on bare metal. There are operator pods that control the other pods. So for each application that we spin up, say we spin up the TensorFlow job operator, we also spin up the TensorFlow job operator pod, which manages the TensorFlow job operator. I have said operator a lot.
All right, so TensorFlow then is a set of tools that run on Kubernetes then, and is it helping me with like organizing my data and getting it through workers that are actually going to do jobs for me? Is it like, what's like a I don't know, closer to a real world example of what kind of thing is it going to do? Is it going to identify data based on a model? Is it going to help me sort and map reduce stuff? Like what kind of stuff is it going to do?
Yeah, so the charms that are in the bundle right now, let me pull up the charm store page. So this is the charm store page. You can go here, jujucharms.com/kubeflow. And the charms that we have in here right now are Jupyter Hub, Tensorflow Job Dashboard, and Tensorflow Job Operator. So the job dashboard and the job operator will let you run TensorFlow jobs. You just submit a TF job, bit of YAML, and the TensorFlow job operator will take care of running it, and the TensorFlow job dashboard will let you see what all jobs you have running. And then the other charm that we have in here is Jupyter Hub, which just like if you're a school or research institution, or you've got a bunch of data scientists and each one of them needs their own Jupyter notebooks. Jupyter Hub is just a way of having per user notebook setup.
Yeah, we've shown that in the past on a non-Kubernetes deploy, where you can basically like write code against a backend in order to like have this kind of pre-programmed and repeatable, run this code and see what the results are, visualize it kind of stuff for me. So Jupyter Hub is very cool. So this is a Kubernetes deployed version of Jupyter Hub?
Yep.
Awesome. And then maybe this is more of a TensorFlow question than a Kubeflow question, I guess, an idea. But the data to get into TensorFlow, is that pointed at like a HDFS situation, or is it a streaming API kind of thing? Like what kind of data does it take in?
Yeah, so that is kind of a big topic, because there may be a number of ways that you want to get data exposed to TensorFlow. Mm-hmm. Probably the simplest way, I'll pull up the script here. Actually, I'll pull up a bit of YAML. So if you create this in microK8s, this will let you create custom persistent volumes, such as this, that you can point at a local path on your laptop or whatever. So if you have a bunch of data that you just have like sitting on your laptop, you can get that into microK8s and just get going with that. For the more production-oriented use cases, like if you've got hundreds of terabytes or petabytes of data, you're not going to fit that on your laptop. You've probably got that on HDFS or something somewhere, and then that is just a matter of, like, say, pointing Jupyter Hub at the right. You point Jupyter Hub at a persistent volume claim, or tell it to create a persistent volume claim, and then you can fulfill that by creating the appropriate Kubernetes constructs.
Awesome. Okay. So that's cool then. So then this is using the new Juju Kubernetes kind of workflows and tooling. Is this 2.6 specific?
This is actually running with 2.5. There are some cool new things that are happening with 2.6.
Darn, I was gonna dangle candy that if you want to do this, you got to try the 2.6 out. But no, you're gonna tell me that you can do it with even stable Juju. Man, well, all right, that works.
If it helps at all, I'm about to break things for 2.6. So.
All right. No, that's good to know, though. That's cool. Appreciate it. I'm sorry. That's my end of my dumb questions for now.
All right. Let's see. Went over those.
So, Ken, you mentioned some early setup before you were able to type Juju deployed TensorFlow. Before you got to this bundle, what did you have to do?
Yeah,
to start deploying K8s charms. And Rick, I think this will tie into what you were asking. You said TensorFlow a couple times versus Kubeflow, so it might be worth noting that TensorFlow, we've seen it before in the big data space, and it's a well-known machine learning suite or platform for developing those kind of applications. Kubeflow is the native Kubernetes platform to do TensorFlowy things. So I think what I'm looking at on Ken's screen now is how to deploy this native Kubernetes platform in a K8s environment.
Yep. Yeah. So there was a little bit of setup, and this is the script that I ran to set things up, and I'll just go through it here. So to start, yeah.
So you had to set up microcates, your cloud you're deploying against, I guess, kind of with some config stuff to make it suitable, right? And
yeah.
Tell Juju about your cloud. So I think those are fairly normal steps for folks as far as setup goes, right? Like you kind of have to tell it what cloud, kind of how you're going to have Juju talk to the thing, and
Yep.
So that's good.
Yeah, and then once we've gone through set up microcates, set up Juju, tell Juju about microcates, we do create a storage pool for the operator pods, and then we can just do Juju deploy kubeflow, and then just expose the reverse proxy to make all the services available to the outside world, and then we're good to go.
Cool. So nothing too crazy there. The storage pool thing, is that go away in 2.6? I think there was some default storage pool work done as part of that.
Yeah. I don't recall the exact details, but I believe that
out. Okay.
Yeah, you should be able to just omit this entirely, and Juju will create the storage pool itself.
Cool.
Yeah. So I guess let's take a look at the deployed Kubeflow instance.
Hey, can you do a status there while you're in your terminal to see what the model looks like?
Yeah, that's a good point. So here's what we've got deployed. We've got Ambassador, we've got Jupyter Hub, we've got the TensorFlow job dashboard, and we've got the TensorFlow job operator. And we have, go ahead.
Yeah, so this is this is your Kates model backed by your microkates cloud.
Yep.
Nice.
Yeah, and so yeah, this is running on microkates, and I will pull up right here. This is just regular microkates dashboard. So if you're familiar with Kubernetes at all, it's exactly what you'd expect. You can see that Juju mapped the model that we created to just a regular Kubernetes namespace. And then you can see the pods that we've deployed. If you're familiar with Kubernetes, it's pretty much exactly what you'd expect. And then the two services that we have in the bundle right now, I'll show you Jupyter Hub first. So this is Jupyter Hub, and you can see that I logged in there as a particular user, and I can spawn up a custom Jupyter Notebook instance for this particular user. So if you got,
sorry, Ken, can you make that a little bit bigger? It's a little small.
Yeah, sorry, that is a good catch. Yeah, so if you got a bunch of different users and you don't want them to conflict with each other, Jupyter Hub is a great way to handle that. So you can see here, I'm about to spawn a Jupyter Notebook instance. And there's a couple of default images, but also if you have a custom image that you want to deploy, you're able to do that. Then we'll take a look at the advanced options here.
So this is interesting in the Kubernetes world. So when you say an instance, we're going to launch a new pod, right?
Yep.
Just launching something in Kubernetes. So it's kind of interesting how a workload is launching off kind of more workloady things. Now this is outside of Juju's purview, right? As far as operating that pod, cleaning it up and tearing it down and stuff, right? Because it's all done within Jupyter Hub.
Yep. Yeah, Jupyter Hub. So Jupyter Hub has some pluggable spawners, and the spawner that we're using is called kubespawner, and that just knows how to talk to Kubernetes directly and does all the work of spawning it and monitoring it.
Very cool.
Yeah. So if you want to set particular CPU constraints, memory constraints, etc., you can add those here. If you have particular data that you need to expose, like we were saying before, if you've created a particular persistent volume to access a local disk or access HDFS or whatever, you can mount that to the Jupyter Notebook instance here. And both of these just create persistent volume claims. So if you're familiar with Kubernetes, however you want to satisfy those persistent volume claims, you're able to. And then if you have any extra constraints that you need to add on, like if you want to do some cool, fancy deep learning stuff, you need some really beefy GPUs, you can add that constraint here. And then once you've filled out this form, you can just hit spawn, and it will go and talk to Kubernetes and spawn this in the background. And this is talking to, relevant to the earlier question. You can see here that we've got this Jupyter Kubeflow pod that was spun up, and this was spun up by Jupyter Hub itself. And that is the pod that we're talking to right here. And just to demonstrate running a notebook, I've got just a pre-existing notebook here. It shows the just running the game of life, which you are probably familiar with. You can see here it's pretty easy to get started. Just, if you've got a pre-existing notebook, you can just upload it or make it available via a persistent volume claim.
Can I just jump in with a quick question?
Sure.
So this, the benefit of this Jupyter Hub provided by Kubeflow is that it actually has all of the access to all the TensorFlow libraries, correct? So you can do like machine learning stuff directly in your Jupyter Notebook?
Yeah. So I'll go to the spawning screen again. Yeah, we can spawn it with whatever image we want. So Google has made some images available that just come with TensorFlow pre-installed along with some other libraries, both CPU and GPU versions. So if you just need TensorFlow and whatever libraries those have installed, great, you can just spin up an image with those. If you need some custom libraries installed, you can create your own Docker image, upload it somewhere, and then deploy it with that.
So that's an interesting point to point out. I know when I played with them before, right, I was playing with some Python libraries and things to do some demonstration stuff, and I'd have to make sure that I had an image set up that had all that, whatever I installed on that VM pre-installed and ready to go, done this way in a Kubernetes environment.
Yeah. And also, if you need to, you can start off with a basic image, and from within a Python notebook or a Jupyter notebook, you can install libraries as necessary.
Okay, cool. Well, that's a nice way to unblock that then. Cool.
Yeah, it's kind of a hack. I mean, the better way is to make it available, as an image with the libraries that you need. But if you need to, you can do that. Cool. And then, so yeah, that's Jupyter Hub. And then I'm also going to show off the TensorFlow job operator and dashboard. So we can create a job by just submitting some YAML there, and then we can retrieve the contents for the template jobs by just doing a git on the TF jobs resource, which for those of you familiar with Kubernetes, the TensorFlow job operator charm has created a custom resource definition that handles the TF job resource. And that is what we have created with the job.yaml is a TF job resource. So we can see here that it is running. And so you can see what is in job.yaml and what we're submitting to Kubernetes. We're submitting a TF job, we're giving it a name, and we're telling it to use a particular number of master and workers. And we're just running a basic MNIST classifier.
Oh, that's interesting. So you're kind of like a master and worker for each job versus like a generic like master worker, like just I don't know. I guess when I played with it in the past, right, you would have like a master worker nodes, and then you would send jobs through the master who would allocate them to the workers or whatever, and the jobs would kind of get spread out. In this case, are they particular to the job in question?
I believe that it's particular to the job in question.
Gotcha.
And yeah, kind of a different way of talking. You don't talk to a master server, you talk to Kubernetes and just give it this YAML, and then the Kubeflow integration knows how to handle taking it from there.
The question: this example job that you have here, did this come from the upstream Kubeflow as like one of their examples?
A little bit indirectly, yes. So we can see here that I've got a Docker file. And the Docker file is pretty simple. It just starts off with TensorFlow 1.5 and then copies this local mnist.py file into it. And this mnist.py is from upstream. And then I just built it like this, and I submitted it to the local microK8s instance as an image called mnist-test. And then that is what lets us, the fact that I built it down with this command is what lets us name that image right here.
Gotcha. Nothing too crazy.
Yeah.
So what does MNIST do?
So MNIST,
Shakespeare involved in any way?
MNIST is just a collection of handwriting samples. It's kind of a classic machine learning, like, I don't want to say benchmark because it's too easy at this point, but basically if you just want a simple problem to try out one of an example classifier on, the MNIST is a reasonably sized data set that there's a lot of other people trying out classifiers on it, so you can know like how well your classifier does. And then to show off the job dashboard, so we can see here the job is done. We see the job first off, but yeah, it's done. We can view the logs from it. Looks like it took about a minute. Yeah, so any jobs that you submit, you can see here.
So is that was training a model then, looking at all the training succeeded steps in the log there? Cool.
Yeah, that was training a model on the MNIST data set.
Gotcha. Nice.
Yeah. And then the last little bit here, just to kind of show off the GUI a little bit.
Oh, now you're making Jeff happy.
You can see here that the GUI works with the Kubernetes instances. We can see the relations here. And we already have all of the relations set up that we need to, but if you needed to, you could find new relationships. You can deploy stuff, deploy new charms if you need to. You can also see the status, which is pretty similar to the command line Juju status.
That's very cool. Good to see that that's updated and working against Kubernetes models like that to help with the visualization side and all. Very nice.
Yeah.
I know there's some work going on to get all this going in Jazz as well, where you can have Kubernetes models running against Kubernetes clusters in Jazz and help with the hosted environment side of stuff. So keep an eye out for that as that goes forward for sure. Awesome. All righty.
Cool. Yeah, that's all I've got.
That was a great demo, Ken. Thanks.
Cool. Thanks.
Speaking of demo, James, did you want to show off your thing that you were showing off in IRC right before when I was trying to get this going, or is that not so public?
I can get it. And after Ken's demo, this will really be just so piss poor. But here we go.
We always want to know what people are doing with Juju out in the wild. What do you got?
Right. So basically, let's see. Got a few controllers here. I've got a MAS controller, and see what models we have there. I basically just created this LexD cluster model in MAS. I don't know if this is the best way in my MAS controller. I don't know if this is the best way to go about doing this, but in this way, I was kind of able to, use Juju to deploy the nodes that I want to be the members of my LexD cluster. And then, so I kind of hook these nodes up with MAS, or deploying them with Juju allows me to use MAS to kind of do a few of the little things that we need to do to drive like consistency for LexD cluster in an automated way. So one of those is like, I want to put my LexD instances on LexD cluster on this VLAN 100 instead of this VLAN 10. And I want to make sure that when I initialize LexD cluster that, all of the bridges to VLAN 100 are consistently named across all of my nodes, cluster nodes. So a few little helpful things that MAS let me do just by making sure that the bridge to VLAN 100 across all of these nodes kind of has the same name or whatever.
And this was like, if you wanted to create a LexD cluster on your own, you would normally turn on a box, log into it, tweak the network config and stuff on that box manually, and you have to repeat that same network config on each box you wanted to eventually be in your cluster. So this way you're getting MAS to do that manual work for you.
Totally, and then getting consistency across my interfaces. So then here we are with those three nodes, and you can see if I look at my clouds, I have a LexD cloud 00, and I think if I my controllers, yep, controller got the name LexD cloud 002, but there we go. So now we're on our LexD cloud and
Redis cluster, huh?
And as we can see, we've got these our Redis cluster charm that we have, or Redis charm deployed in with Redis cluster mode enabled, deployed across all of these across my LexD cluster. So in this way, PD on MAS. If we kind of get into one of these boxes here, we're on LexD cluster list. You can see those three nodes. I can run LexD list. Yep, LexD list, and we can see all of the Redis cluster is
D3, D4, D5 all getting spread out. Nice.
Totally. And then to kind of cap it all off, get back over here and kind of hop into one of these machines. And we can actually use the Redis CLI, look at our cluster nodes. And if if we were to kind of add up all of these segments of range of the broken up ranges of slots, Redis cluster kind of distributes slots across cluster nodes. We would see that each of these nodes has an equal amount of slots down to basically give or take one slot to make up for the division of odd numbered clusters. So yeah, that's kind of it. And I built this cool little bit into the Redis cluster charm, or the Redis charm that on stop, the charm will actually call out to the Redis CLI, and it will rebalance all of the slots away from the node that's leaving the cluster before the node leaves the cluster. In this way, we can kind of scale Redis cluster up and down. And I also have this a way to rebalance the slots on the cluster when a node is added. And so in this way, we can kind of scale Redis cluster up and down and have the slots redistributed dynamically depending on whether or not a node is entering or leaving the cluster.
So that's really cool. So what I love is like you're using like a LXD cluster to very densely work on your operations code that when you take it to production, you'll have assurance that it works and scale out with 15 machines because you tested it with 15 machines in a LXD cluster without having to say, okay, everyone, I'm borrowing this rack for the day to test out my charm changes. That's pretty sweet.
Totally, and we can even take this to production. Redis is such a, it's such just a memory, like a little memory consumer that, you know, we don't need any disk IOPS happening. We only need very small CPU power per Redis instance, and we really just need, you know, 16 to 30 gigs of RAM per instance. And so, you know, for us to just kind of use this to the extent that we need to just get the bang for our buck out of the memory and the throughput that we need to get fast IOPS in and out of Redis, it's just the perfect little solution. It allowed us to kind of get there quick without jumping through the hoops. You know, our initial goal was to put an OpenStack in place, and then we'd have this great private cloud to deploy all of our Redis cluster use case on. And, you know, I still think it's a great idea, but in the interim, in the time that it kind of takes us to get OpenStack up and running, this was, you know, we could use LXD cluster to kind of get an immediate solution out of this Redis cluster space that we're toying with here. So, okay, that's all.
That's awesome. That's fun. I know some folks on the team will love seeing folks putting that stuff to work. That's one of those, again, speaking of things that are kind of, I feel like are underutilized. I think LXD clustering is something that's got a lot of potential for folks to really play with in that scale up, but not all the way up kind of thing. Like there's a lot of times when you need that middle ground layer. I think the LXD clustering is awesome for that, especially like small work groups and stuff. Almost makes you want to go back. Remember, it used to be like the little work group server you would buy that would run like the little suite of software for your like, you know, group of 5 to 7 people or whatnot. I feel like we need like a little LXD cluster for that where you, Windows work groups.
One more thing, a little LXD cluster. If you notice, you know, these are beefy nodes. They each have 88 cores and over 700 gigs of RAM, and they're DDR4 nodes. So you know, we put a decent amount of effort into and money into just getting some legit compute nodes to facilitate our LXD use case here. So yeah.
My apologies. I thought you were playing around with like development stuff on like a few servers sitting over in a corner, but when you said we could do this with production, you weren't kidding. I didn't catch that the first time that Maz screen went around. I'm like, oh, you could do this for like, you know, 3 people in a corner, and you're like, or you could run all your production stuff at full bore. Not worthy, Beatty. Not worthy. All right, let's get out of here. We've gone way long today, but it's awesome, and I missed you guys. So everyone, have a good time. See you in a couple of weeks because I'm out next week. Spring break. Woo! All right, have fun, everyone. So long. Bye.
Thanks.
Thanks.